In this section, we'll cover the limit of a function. Recall from the past section when we found the slope of a tangent line by getting 2 points and on a curve closer and closer to one another. This allowed the secant line between the 2 points to approach the tangent line at one specific point. Notice that there is no limit on how close we can get these 2 points, but the idea is that they become closer and closer without equaling each other. To improve upon this technique of finding slopes of tangent lines, we need to first understand the concept of a limit. The notation limit as x approaches a of f of x equals L means that as the input x gets closer and closer to the value of a, the output y gets closer and closer to the value of L. We say the limit as x approaches a of f of x is L. There are 3 different ways that we can evaluate a limit: graphically, numerically, and symbolically. Graphically, we can look. So let's say that we were looking at this function. Let's call this red line function f of x, and we're looking at what happens as x approaches 1. So if I'm looking at, here's 1, so what happens? What's going on with the function? So as x is approaching 1 from either direction, the y value is approaching 2. So we'd say the limit as x approaches 1 of f of x is 2. Numerically, we could look at this as a table of values. So you can see here I have values that are getting closer and closer to 1 from either direction. So from numbers that are lower than it and numbers that are larger than it. And when we do it, so we're super close to 1, not quite 1, but super close to it, we can see what's happening with these y values. They are approaching 2. So as x is approaching 1, the y values are approaching 2. So again, we'd say here the limit as x approaches 1, and in this case, this is g of x equals 2. Now, we're going to learn about limit laws and how to do this symbolically in a later section. Let's look at an example, evaluating a limit graphically and numerically. Evaluate the limit as x approaches 0 of sine of x over x using its graph and then using a table. So what you see here in this image is I've graphed f of x equals the sine of x over x. You can see that this graph is undefined at x equals 0, and that's because you can't have 0 in the denominator. So let's see though what happens as x is approaching 0. So again, what's happening as x is approaching 0 for this function. So we're going to look on either side of 0. So as we're getting closer and closer to 0, we can see the function is approaching 1. And as I get closer and closer to 0 on the right-hand side, we can see that's also approaching 1. So graphically, we can see that that limit is approaching 1, or the function is approaching 1. We can see this numerically in a table where if we plugged in a bunch of different x values, again, you can see these x values are getting closer and closer to 0. So I use a value that's like 1/10 away, 1/100th away, 1,000th away. So all that this value is just having us put this x value into the function for x and getting an output function. So when we do that, again, we can look and you can see that these values are getting closer and closer to 1. So again, we'd say the limit as x is approaching 0 of sine of x over x is 1. So that means that the function, as it's approaching 0, the y value, the output of your function is 1. Or approaching, it's approaching 1. Example, evaluating numerically. Evaluate the limit as x approaches 4 of the square root of x minus 2 over the quantity x minus 4 with a table. So to do this with a table, you can use your calculator. You can also use Desmos or GeoGebra. I prefer to use Desmos. I'm going to show you how I do that. So you first go to desmos.com and then go to the graphing calculator. And what we'll do here is we're going to type in the function. So in this case, the function was f of x equals the square root of 2 or of x minus 2. And then that's all over. So let's put that in parentheses. All over the quantity x minus 4. Okay, so you can kind of see what's going on graphically here. I'm going to get rid of those so this isn't so ugly. Okay, So you can see what's going on graphically here. We can kind of look at it and see, okay, as x is approaching 4, it looks like we're getting close to a number that's a little bit less than 1, but less than 1/2 even. But let's look at, instead of just trying to eyeball it, let's get a more of an accurate idea of what's happening by using a table of values. So once you have this in Desmos, all you need to do is go to this circle edit list. And when you do that, this option for a table is going to pop up. So you're going to click on that. Now, we want to look specifically, this limit is asking us to find out what happens as x is approaching 4. So let's pick some values that are above 4 and below 4 to see what's happening at our function at those values, because we know that when we plug 4 in or substitute 4 in for x, we're going to get 0 in the denominator, which is undefined. So let's first start with the number. I usually try to do a 10th away, and then we'll do 100th away. And then 1,000th away. And then I'll go from the other direction, which would be 1,000th away from numbers that are less than 4. And then 100th away. And a 10th away in that other direction. So we can see here that as your x values are approaching 4 from either direction, your function is approaching about 0.25. So that's what we can say, is that the limit as x approaches 4 of the square root of x minus 2 all over x minus 4 equals 0.25. What can we do if we happen to have a graph like this? Can we find the limit as g approaches 2? So right now, if I look at that as g approaches 2 from numbers that are smaller than 2, I'm approaching 1, -1, values that are larger than 2, I'm approaching 1. So we have a problem here, whereas I'm approaching 2 from either side, I'm getting different answers. So this is where one-sided limits come into play. One-sided limits consider the direction in which you approach A from. So approaching A from the left means that the values you're using are smaller than A. So for example, if this is our point, values to the left of it are values that are smaller than it. So in this case, I would say the limit as we approach 2 from the left is -1. The limit as I approach 2 from the right is +1. So the way that we write that notationally is this way. So you write the limit as x approaches 2, but now what we need to do is we need to say where it's coming from. So in this case, we'd be saying, and actually I should use A here so that we have this generically. I'll do it with the 2 over in this direction over here after. So as x is approaching A, so when we're talking about from the left-hand side, again, we're talking about values that are smaller than A. So we put a little minus sign up there. That's how I remember it. And then of f of x. And then if we're talking about the right-hand limit, this would be the limit as x approaches A from numbers that are larger than it of f of x equals L equals L. So for example, over here, I would say the limit as x approaches 2 from numbers that are smaller than it of g of x, because this function is called g of x, is -1. The limit as x approaches 2 from the right, so we get numbers that are larger than 2, of g of x is +1. When those two are not equal, then the actual limit does not exist. So the limit as x approaches 2, because we don't have an actual value that we're approaching to from either side. So let's look at this graphically and do some examples with this. Use the graph of f of x below to determine each of the following values. The limit as x approaches -4 from the left of the function. So x is going to approach -4 from the left, so numbers that are smaller than it. So that is approaching 0. The limit as x approaches -4 from numbers that are larger than it. That is also approaching 0. So since those are the same, we can say that the limit as x approaches -4 is 0. If we try to evaluate f at that value, we have a solid circle there. We have an actual point, and that's 0. All of those line up. Let's look at one where maybe it doesn't. So if I look at approaching -2, so as I approach it from numbers that are from the left, so again, numbers that are smaller than it, the function is approaching 3. Other direction, same thing. So that means the limit exists, and the limit is 3. So again, as long as the limit from the left and the right are approaching the same number, then the actual limit at that number exists. What is f of -2? Well, f of -2, there's an open circle there. That means it doesn't exist. So we'll say does not exist, or another way that we write that is DNE. All right, let's look at some more. The limit as x approaches 1 from the left. So again, from numbers that are smaller than it. All right, so 1 is right here. So as I'm approaching it from the left-hand side, that function is approaching 6. As I approach it from the right-hand side, that function is approaching 3. Now, looking here, the limit as x approaches 1. I'm going to make that 3 a little bit prettier. So because on the left and the right I'm approaching different numbers, this limit does not exist. What is f of 1? Well, f of 1 is 6, because that's where we have that solid circle. All right, let's look at -3. So at -3, or sorry, at +3. So at +3, as we're approaching it from the left, we're going down to -infinity. As we approach it from the right, it's going down to -infinity. So we'd say, as you're approaching 3, since both of those went towards -infinity, we would say -infinity. And we would say, so what's the value of f of 3? Well, f of 3 is not defined. So does not exist, or undefined.